We are going to discuss about fan regulators. Fan regulators, the old ones, which were heavy, large in size, bulky, unwieldy, cumbersome. And now we have got sleek, tidy, and small sized regulators. But apart from that, what is the difference between old regulators and new regulators? Old fan regulators were called resistive or resistance based, and the modern regulators today, what we use, the sleek model, they are called capacitive or capacitance based. So old fan regulators were resistive or resistance based, and the new ones we use are capacitance based or capacitive. What is the difference and how do they work, and which is better and why? Which is better and why? We shall explore fan regulators, which regulators are better and why. The old regulator, which we call resistive regulator or resistance based regulator. The regulator was heavy and bulky, large size and very heavy. The regulator became very hot. In fact, they were provided with openings or slits called heat ventilation slits to let the heat escape. They became very hot. And the regulator wasted power. So the regulator was heavy, the regulator was bulky, large in size, they became hot, we had to provide heat ventilation slits to let the heat escape, and the regulator wasted power. That was the old regulator, that is resistive regulator or resistance based regulator. Here we have a brief description of how the resistive or resistance based old model fan regulator used to work. You can see the speed setting 1, 2, 3, 4, 5, and between them we have got resistors. R1 connecting point 1 and 2, R2 connecting 2 and 3, R3 connecting 3 and 4, and R4 connecting 4 and 5. So if the regulator is set to 1, the current will have to pass through resistors R1 plus R2 plus R3 plus R4. If you set at speed 3, then the current would pass through resistors R3 plus R4. And if you set it at speed 4, the current would pass through just one resistor R4. And if you set it at speed 5, then no extra resistance. So resistors in series, this is how they work. And the lower speed you set the fan to, the more number of resistors the current had to pass. So what happened was, the extra current which was not going to the fan was changed to heat. Current passing through resistors will produce heat in the same way as your electric heater. You have your electric heater, the heating elements. When current passes, the resistance to the current, that is what results in heat production. So here also, when current passes through resistors, heat would be produced. That's the reason why the regulators became very hot. In addition, since the extra energy is being changed to heat, you do not save the power. You do not save the power. The voltage remains the same. Part of the current goes to the fan and part of the current is changed to heat energy. So you are not actually saving anything. The voltage remains constant, 220 volt, always 220 volt. But what happens? The current passing through a series of resistors, that means extra resistance, would produce heat. So the power, the electrical energy would be converted into heat energy. So practically they are wasted. You do not save the power. You do not save electricity. Electricity is being changed to heat energy. Modern regulators are capacitive or capacitance based. Capacitance, reactance. In an AC circuit, AC means alternating current. In an AC circuit, a capacitor creates opposition to the flow of current, known as capacitive reactance. This reactance is inversely proportional to both frequency and capacitance. Now what happens? Voltage division. By wiring a capacitor in series with a fan motor, the total line voltage gets divided between the capacitor and the fan. The capacitor absorbs a portion of the voltage, resulting in a reduced voltage reaching the motor. So here voltage is reduced. Their voltage in the old type regulator, voltage was always 220. But here the voltage is reduced, voltage is divided. So voltage reduction results in lower motor speed. Adjustable speeds. A multi-step rotary regulator houses several capacitors of varying values, measured in microfarads. When you set it to a lower speed setting, the regulator switches in a capacitor with a smaller capacitance value, which creates higher reactance, dropping more voltage and slowing down the fan speed. So you are decreasing the voltage rather than changing the current to heat energy by passing through extra resistors. So you are using a capacitance. What happens when you set it to speed 1 or 2? So the regulator switches to a capacitor with smaller capacitance, which results in dropping more voltage, and that is how the fan speed is controlled. So the advantages of using new regulator. First is energy efficiency. Because capacitors store and release energy, they barely heat up, saving power at lower speeds. In the old regulator, the way in which the old regulator worked was to change the extra energy to heat energy. Whatever you don't need, if your fan is working at a lower speed, the extra electrical energy was changed to heat energy, and that heat energy was wasted, released through openings or ventilation slits. Here the extra energy is not converted into heat. It is stored and released and reutilized, so you are saving power. Secondly, durability. With no excess heat generated, the internal component experiences much less thermal stress over time. That means damage due to extra heat is avoided. Old regulators, which became very hot, the damage was there. Damage due to excess heating, that damage due to excess heating is avoided. So it becomes more durable, longer lasting. Power returned. The power stored by the capacitor is returned to the AC power source during the next half of the electrical cycle. So you are not converting the extra energy to heat and dissipating it, but it is returned to the AC power source so that it can be recycled or reutilized. As they run on AC, they do not waste power, they just cycle energy back and forth. And lastly, charge and discharge cycle. In the first quarter cycle, that is a charge cycle, the AC voltage rises, pushing current into the capacitor. The capacitor stores this energy inside its internal electrical field. It stores, it doesn't change the extra electrical energy to heat energy. It stores that energy. In the second cycle, that is a discharge cycle, the AC voltage drops back to zero, alternating current. So the voltage will fluctuate from plus 220 to 0 to minus 220. So the AC voltage drops back to 0. The capacitor discharges. That means now the current is flowing in the opposite direction. It is sending the stored electrical energy back into the circuit toward the power source. So when the AC voltage is high, say 220, current will flow to the capacitor. But when the AC voltage becomes 0, the current will flow back from capacitor to the power source. So it is just recycling and reutilizing the extra energy. It is sending back the unused, unutilized, stored energy. It is sending back to the power source. It is not converting it into heat. So that is how you save the power. The extra electrical energy will not be converted to heat, but it will be stored and recycled, and when the AC voltage drops, it will be sent back to the power source. Again, when AC voltage rises, the current will again flow to the capacitor. So what happens? The extra energy is not wasted. So that is how you save the power, and this is how the power is saved, sending the energy back and forth in the charge and discharge cycles. So finally we can compare the old regulator and the new regulator. In the old regulator, energy wasted, and in the new regulator, energy conserved. In the old regulator, extra power turned to heat, and in the new regulator, very little heating. In the old regulator, thermal stress means excess heating affects durability, and in the new regulator, better durability and longer lasting, because damage due to excess heating is not there. Old regulator works by adding resistors, and the new regulator works by varying capacitance. The old regulator was large and heavy, and the new regulator sleek and light. So this is the comparison, and now you can see why we use the new capacitance based regulator and not the resistance based regulator.